So, Mayker is a company that is based in Belgium, and we are focused in these three main areas. So, we deliver assessments and architectures to our clients. We also develop solutions and applications, and we also have a practice of analytics and IoT. And to give you an overview, we started this journey in 2022, and now we are about 50 people in the company. And we are based mainly in the Benelux region, and we also have some international projects. Our expertise is mainly in the manufacturing industries, also a bit energy and logistics, but we want to focus on companies that make stuff. That's why Mayker. And we also have lots of low-code development projects. That's a bit of a separate topic. And and the data and analytics side that we mentioned before. We are active in various industries, like I was mentioning. So from food and beverage to mining to pharma, etc. And these are some of the names that we've served in the last years. So I'm going to go really quick through some of the IT/OT challenges and the kind of unified namespace basics, just within some context. But as I was saying, many of this stuff has been really well explained. I think especially Mark and Matthias gave really good presentations about this. But a bit my view on challenges. So traditional IT/OT architecture, different sides, connecting data from the OT side to IT side. We have challenges with many different systems, having to integrate them. We have data silos. We have problems with the manual processes or data that is manually introduced into systems. We also have lots of talk about how to properly add context, maintain data quality. Importantly, security-wise, how to reduce the surface of attacks. And that's actually an area that, especially in the last year or a couple of years, we've seen growing a lot. And finally, scalability of these architectures. How do we do this? And that's where UNS architectures can come in and help in many of these challenges. And a bit of a borrowed slide from HiveMQ presentations, but the traditional ISA95 triangle, where different systems communicate with a level next to them, it's a little bit broken down by modern or newer technologies like IoT, where nowadays all systems can kind of talk to each other. And that's where Unified Namespace can come in and help organize this architecture, bring you a single source of truth, give you organization to the architecture, help you manage the data, etc. And to give you maybe a bit of a very high-level overview of what the UNS architecture might look like, we've seen lots of architectures like this one displayed nowadays. So this is a really high-level view, but essentially we might have on-premises, on the sites, edge gateways that allow you to do some data modeling and also to convert protocols from industrial protocols to MQTT or other protocols. As I was saying, we're using edge gateways on the sites, also to process data on the edge, etc. Then data typically goes through firewalls to enterprise-level brokers. There can be federated layers of brokers, of course. This is very simplified. There are also other systems on site connecting to edge brokers, for example. And then the broker helps you get that data to all your consumers. And let's get to the part of data modeling with Node-RED. So I'm going to start with some kind of introduction of what we mean by data modeling. And then I will give you a short demo of actually using Node-RED for, I will demo it, how we do it, or demo some custom nodes that we developed to do this in Node-RED. But let's start with why we do this. So a very common saying in manufacturing industries, the garbage in, garbage out. Of course, this also translates to data being sent to a broker. We all know and have repeated multiple times that just sending raw data to the broker will not really help you. You need to do something more than that. But then we might think, okay, nowadays we can also use machine learning. Maybe machine learning can solve the problem. But if we use machine learning, we still have the same problem. Like the models, if they get bad data, they will not magically fix it for you. But then this can get better because now we have artificial intelligence. Artificial intelligence might help a little bit, might make the sheet sparkle a little bit, but it's still, deep down, it's the same issue, right? But now we have generative AI. Generative AI makes very beautiful shit. But deep down, we know it's still the same inside. And lastly, LLMs, or agentic AI, sorry. That makes you very different kinds of beautiful shit. But yeah, sometimes it might be good enough, other times it might not. But actually, this is a bit of a joke because we were discussing before about how actually this might be a feasible future for adding context to data, to use AI to really find out where that data comes from, or build models that can actually bring value and help you add context to your data. And that's a really promising feature of AI. It's something that we're definitely going to be looking at. But what is data modeling for us? So it's basically structuring your data, adding your raw data, adding context, and make it understandable. So that's really basically what we mean. And one possible question you might have is like, why use Node-RED, or why adding context at the edge with Node-RED instances? And it's good always to have this work done as close to the source as possible. So everyone that receives the data from the beginning already has it with the proper context. And then it also reduces network load or adds context before it leaves OT. And what we mean by machine models, these are digital representations of our assets, like, for example, a filler or a conveyor, and their data. So attributes like speed or temperature, product count, etc. And what we mean by contextualizing is changing something like tag 101 to like a full name that really means something to us. And of course, adding context to the payload, etc. So what I'm going to use to explain how we do data modeling is to talk about instances, models, and attributes. And what I mean by an instance, it's mostly a physical piece of equipment, and that uses a model. So that can be a specific conveyor or something like that. And a model, it's a blueprint that the instances acquire or use to represent themselves. So model is a standard definition of a type of asset, and we define what information is relevant for that asset type. And finally, attributes are the specific data points of each model. So we define the characteristics of and measurements of the asset type with the attributes. And here's an example of a hierarchical machine model structure. So you see, we start, or we organize it still using ISA 95 hierarchy. So a site, an area, and a line. And then when we go deeper into the line, in this case, we find that a line can have different instances. So it can have a conveyor, a filler, a sealer, a labeler, This could be a packaging line, for example. So we define the model of a packaging line as a model that has these 4 machines inside. And then inside each machine, we develop a model for the specific equipment that has the attributes that we find. And then we can put all together and say this is the whole data model or information model for our production line. So let's see. And why using Node-RED for data modeling? And at the end, Node-RED is a very flexible platform. You can do tons of things. Most people start using Node-RED for home automation projects. That's, I think, how 90% of the people start using Node-RED. But then they end up realizing that they can also use it at work. So yeah, they are already used to it, and then they find out how useful it can be at work. But I want to mention that indeed Node-RED is an open source tool that is very useful. But for enterprise applications, you are sometimes lacking some features to manage at scale. And that's where I find FlowFuse a very interesting framework around Node-RED, or a very interesting company that offers like enterprise Node-RED solutions. And we work a lot with them to scale up really extensively Node-RED deployments. And yeah, so I encourage you to also find out more about it if you're interested in using Node-RED at enterprise level. And yeah, essentially, as you know, it's good for prototyping, but like I was saying, that you can expand a lot with using tools like FlowFuse. But the challenge is that data modeling can be complex, even for powerful tools. And the solution, or one possible solution that I want to show today, because we've seen with Pulse, other tools like HiveMQ, you can also do a lot. But this is a really accessible way of doing data modeling with Node-RED. And you can also create pretty complex stuff. So let's see. I think, yeah, this is what I'm going to demo today. So to give you a bit of an overview, it's a very basic setup, all made locally in my machine here. And it's simulated OPC UA data. We have an OPC UA browser node that we created to just browse the OPC UA data and select the tags that we want. And then we're going to use what we call a modeler mapper node to define data models, the model attributes, and then create asset instances, and then map the OPC UA data to the correct fields in each instance. And then you can send this data via MQTT or any protocol, actually. So yeah, let me go back here and see if I can at the same time hold the microphone and and do the demo. Let's see. Yeah, let me get out of the presentation. All right. So you can see here a very simple Node-RED flow, or let me explain a little bit more what we have here. So we have an OPC UA server that we connect to. So this is actually a public demo server that you can all connect to if you want to for free. And we have here our OPC UA selector that allows us to browse this server and select some tags that we want to map to a model. So that's the basic start of the flow. And what we have here, our main node that we develop, is this mapper node. And what you see here is that we start by selecting a data model. So I'm first going to go deeper into into this model and show you how that's created. So I have here a model that, or different models for different machines. And so we can start by showing, okay, a model of a conveyor belt. So for example, I would have here a conveyor belt that has 4 attributes: speed, part ID, status, etc. And then we have a similar for filling machine, sealing machine, labeling, etc. And then we have at the end what we call a packaging machine that would be a combination of multiple machines. So the packaging line or machine inside contains the model of the conveyor belt, the filling machine, sealing, labeling, etc. But then we also have a machine ID, status, and some higher level properties. So that's the start of creating our model. And what we then want to do is to assign this model to an instance or an actual equipment. And then here we will just define which model we're going to use for this packaging line, and how often we want the data to be sent. And once we are happy with our model, we define, also note that we are defining here the data type for each attribute. And now that we have the model defined, we go to define the actual mappings from the different OPC UA tags to the different attributes. So we have here a list, or we can add as many attributes as we need, and we can define for each attribute. So here we have all the attributes that we previously defined in the model, and then we define if it's a constant value or if it's mapped from a message. That can be a message that we are building in the flow. Like, for example, here I have these status nodes, and we can say like, oh no, this is a message that is coming from another Node-RED node, or we can map it from the OPC UA tags that we are browsing. And when we do all this, we end up generating our whole JSON message. And if we look at the broker, so I have a very basic setup with just one topic to keep it very simple. And we are, instead of receiving an OPC UA message, we're receiving a full JSON with the different attributes that we defined. So we defined that there's going to be a conveyor belt that was going to have a part ID, and we mapped the correct OPC UA tag to each attribute, and then we see it here. And then, so we have some empty values that I haven't mapped, but I can show you really quick how I map it. So for example, I see a sealing machine. I might know that the sealing machine has so the filling machine level, for example, we might know that this can be mapped, let's say, to a different OPC UA topic node. So number 4. So we can do this, deploy it, and we should start seeing the sealing machine, or did I add the filling machine level? I think I added. Was it the filling machine? I added, yeah, the filling machine level, or maybe let's add actually a sealing machine temperature, because that one was already there. And then we will see that, yeah, the sealing machine temperature starts to show here. So that's very basic, but you can see a little bit how we start with building this data model, and how we can send it to an MQTT broker. So if you have any questions later, you want to go deeper into this, just feel free to come, and I'm happy to show you more or discuss more how we could continue improving this tool as well. But back to the presentation, since I think we have like 15 minutes left. Mm. All right. So what we showed in this demo is very quickly how we can convert some raw data to a more enriched JSON message. But I didn't mention this JSON message that I shared might not be the best JSON message for every company. And we've had quite a few experiences with how to define the best payload specification for each case. And sometimes we've taken, for example, the Sparkplug-B payload specification for JSON, converted it to JSON, and defined that JSON format as the standard for the company. Sometimes we just create a JSON file and we say, okay, in this company, we just need to have a timestamp, a status, and some metadata, and we fill it all there. But in any case, it's always very important, and I think it was mentioned also this morning in several talks, that we document and we define a standard that we're going to follow. And here I just want to mention a standard that we've been dealing with recently, and it's really simple and flexible and might be interesting for you to look at if you want. It's called Cloud Events. It's from Cloud Native Computing Foundation, and it's a simple model to standardize event metadata, and it's proven quite complete and useful for many of our cases. So feel free to take a look. If you have any questions, then you can also always come back and ask me about more details. But yeah, it's definitely something we're starting to like a lot. And something that I also want to mention is that one side of unified namespace data modeling is what we've been discussing now, the payload formats and what data to include in the payloads, how to model equipment, etc. Another part that we haven't discussed as much, but could be considered part of the information model, is also the topic namespace design. I think we've discussed quite a bit about it. The ISA 95 model, it's in general quite useful for defining the topic namespace, but there might be exceptions at the end. We always say that this is something flexible for each company. We might find some small tunings that make it better for them. And yeah, now I'm just going to go through some example projects, implementations that we've done, where we've used Node-RED, where we've used HiveMQ, other brokers. The first one is a project that we did. Actually, this was, I think, a food company where they wanted to increase efficiency, essentially, and where we helped them implement a new IT/OT infrastructure using Unified Namespace. And in this case, we also went down to the hardware layer and retrofitted some sensors in the production lines to get some data out of them that it was not available before. We also work connecting historian systems to the MES using the Unified Namespace infrastructure, and also work with standardizing. So typical full Unified Namespace project. Here are just some example Grafana dashboards of what we're able to show at the end, and also the sensors that we installed on the production lines. So if you have any questions, feel free to ask. Another interesting project we had, very standard case of need for a unified namespace, company with issues scaling up their current architecture, fearing some security risks, also with lack of governance, lack of unified IT and OT team as well, and in general missing a full end-to-end architecture. And typically how we start engagements like that is to do some kind of initial assessment, trying to map out all the existing systems that are being used. And then we try to define what is the to-be situation going to look like. And we follow with proposing the right technology for each case and implementing it. In this case, we also are using FlowFuse as the general edge platform. We also integrated devices with MES systems, going through the MQTT broker, but also in some cases going through from the MQTT broker to tools like MuleSoft, also to connect with the ERP side. And we developed custom protocol converters, integrated external party data to the UNS. So these are really also complete example of a project. And the last one, maybe a little bit similar in some aspects, but more focused on energy monitoring. And this one was more Node-RED heavy, let's say. But the background was a bit similar to what I already explained. But at the end, it was more focused on implementing energy monitoring solutions and so it was about essentially getting data from historian databases and use it to improve energy KPIs. And again, basic example of how a real UNS topic hierarchy might look like. And also Node-RED dashboard there, which has also improved a lot in the last years. And you can use it for small user interfaces and stuff like that. So that's also something to look out for. Let's go to some lessons learned. So first, this morning we had a really good talk about the first 12 weeks of your UNS journey, and really aligned with what Mark explained should do in those first weeks. Here, I just want to remark, start with proof of values, find really relevant use cases that will deliver value, and develop quickly first applications, and then iterate, scale up, expand to different production lines, etc. And always continue optimizing and improving. And important also to foster the data culture in the company. And to summarize some important points in data modeling. First of all, what I was saying is start with the business value, then embracing semantics and reusing machine models, so create standardized machine models that you can reuse in other places. Always try to iterate and improve the approach. Important box down there, collaborating between IT and OT. So we typically also recommend trying to build joint IT, OT teams, or at least ensure really close collaboration. Then use unified namespace hierarchies and work on governance and standardization. And some bit more extensive list of challenges and solutions. So when we find diverse OT data formats and protocols, use edge tools like Node-RED to normalize this data, or like the Pulse agent, for example. And I've had some very good experience also using directly HiveMQ Data Hub for processing your messages in flight while they go through the broker, and dropping them or adapting them to make sure they follow the specified policies. Then convert your raw data into the rich data model. We typically deal with very large amounts of real-time data. So also use smartly edge platforms for filtering, aggregating, and enriching your data on the edge. Deal with data silos and the lack of single source of truth with central unified namespace architecture. And then a bit of a repetition, but the model well the data and document and document everything properly to be able to help IT struggling interpret your OT data. Use standards or establish standards and then use them, and direct that if possible from corporate level. And finally, resistance to change or skill gaps. That's, of course, most companies a big challenge. And I think there what can help a lot is to start with pilot projects and small trainings and really try to upskill the workforce to help with this issue. And just the final conclusion. I think it was clear, but thank you very much. If you have any questions, go ahead.